Welcome to this tutorial on essential tasks on Tux, a Linux-based system. Today, we'll be covering everything from logging in to setting up a virtual environment for Python development. Let's actually start by logging into Tux. If you're new to Tux, it's a powerful environment commonly used for development and research. Tux is a high-performance computing environment commonly used in academic and research institutions. It provides a powerful computing infrastructure for various scientific computations, simulations, and data analysis. As a user, you can remotely access Tux using Secure Shell (SSH) from your local machine. Tux supports Linux-based command line operations, making it an ideal environment for scientific computing and large-scale data processing. So here you can see that I've logged in using my Drexel ID and it asks for your Drexel password. So basically you give SSH with your Drexel ID at tux.cs.drexel.edu, and then when it asks for your password, you just enter your Drexel account password. And then once you log in, you get a welcome to Tux message. So now you are logged into the system in Tux. And next we'll see how to access GPU nodes on Tux. So Tux offers dedicated GPU nodes to accelerate computations involving floating point operations, and GPUs are specialized processors designed to handle parallel processing tasks, making them particularly effective for scientific simulations and machine learning. And Tux has two GPU nodes named Float and Double, and these nodes are optimized for tasks that heavily rely on floating point computations. Float and double represent different precision levels in floating point arithmetic, catering to specific computing needs. So you can either give SSH float or SSH double to actually set up this connection. So to access GPU nodes directly, we use these commands based on the project requirements. So for my project, I'm using SSH double, and again it asks for your Drexel password and you enter it. So now you have entered this connection. This connection actually allows you to work in an environment optimized by GPU, optimized for GPU accelerated computations. So now once we've logged in, we can actually navigate the file system using commands like ls to list files and cd to change directories. So once you give ls, you can see whatever directories are already there in your system. So here you can see the directories that I have. So if you type cd, you can change directories, like from one you can go to the other. But now let's see how to make a new folder and work with it. So here I've given the command mkdir, which is to make a new directory, and my directory name is mlnew. And once I've made the directory, I use cd mlnew to actually get inside that directory so that I can start working in it. Once we've connected to the GPU node, the next thing we have to do is activate a virtual environment. So activating a virtual environment for a project ensures that the dependencies, including GPU enabled libraries, are isolated. So we can create a virtual environment, and then once we activate it, all the libraries that we import will be local to that particular environment only. So here we'll be creating a virtual environment using Python's venv module and activate it. So I've used Python 3 -m venv and then the name of the virtual environment, which is, here I gave ml. So that will create the virtual environment, and the next command, source ml bin activate, will actually activate the virtual environment, and then I can start installing the libraries that I want. For example, I've shown pip install numpy, so I'm installing numpy here, and you can see that it's successfully installed. So like that, depending on the project that you want, depending on the project that you're working on, you can install multiple libraries. Version control is crucial for collaborative projects, and Git helps manage different versions of code and facilitates collaboration. So now we can see how we can clone a sample Git repository using git clone command. So here I enter git clone, and then I actually paste the link of the repository that I actually have to clone. So git clone and the link of the repository will actually clone the entire repository on Tux for you. And then once you give ls, you can see that density based classifiers is already cloned into uh, the ml new directory that we have created. And wget is another handy tool for downloading files from the web. So let's use it to see how to download a file. So here I've this data set. I copy the link and I give wget space the link of the file. So here we can see that that is also successfully saved. So next, when you give ls, you can also see that that csv file is part of the directory. Now that we have everything that we want to run a Python file, let's take a look at a Python script in the clone repository and run it using Python 3. So for this, I am going to go back to another directory where I have already installed all the packages that is required for my project, and that is basically the ml project virtual environment. So in that virtual environment which I have created, I have all the required libraries installed already. So again, the command to activate ml project virtual environment is source, the name of the virtual environment /bin/activate. So now we are in the ml project virtual environment. So then I have to get into the density based classifiers directory. So basically you run it using the command python 3 space the name of your Python file, and then you can see that it's successfully running. You can see a lot of warning messages which you can just ignore, but the code is actually running and you can see it on the screen. So this actually concludes our tutorial, and in the last few minutes we have learned how to navigate Tux, logging into Tux, setting up a virtual environment, access GPU nodes, and accelerate your computations using GPUs. These skills are crucial for scientific research, machine learning, and various computational tasks. Remember that Tux provides a powerful platform for your computational needs, and leveraging GPU nodes can significantly boost the performance of your projects. As you continue your journey in scientific computing or machine learning, explore further, experiment with different libraries, and don't hesitate to dive deeper into the capabilities of Tux.